I'm Tim Ventura, and we're joined today by Dr. David Stuckenberg, a national security strategist, entrepreneur, inventor, and global influencer. In 2018 and 2019, NATO named David a young disruptor. He's been called the George Kennan of this century by senior military leaders and a national treasure by the 16th Director of Central Intelligence, Ambassador R. James Woolsey. David's experience includes past roles as an Air Force Strategic Policy Fellow, military advisor to the Department of State, and director of the Electromagnetic Task Force on the Joint Staff. He currently serves as the COO of Genesis Systems, combating global water scarcity. And he joins us today to discuss the scope and impact of water scarcity and how his company, Genesis Systems, is working to provide water security around the globe. So, David, welcome, sir. It is truly an honor to have you with me. Thank you for your many years of service. Let me start out by asking if you can give me kind of a brief overview of what Genesis Systems is as a company and your goals, and maybe a little bit about your background and how you came to be the co-founder and CEO.
Water is the economic potential engine of a nation. And when that water runs out, all economic activity and all life stops. And so over the last 5 years, and increasingly in these last few months, all over the world, my organization and my colleagues and I have been in dialogue with ministers at embassies, prime ministers, ambassadors, who are furiously concerned about what is happening in their nations and in their regions. For example, we heard from a government entity in West Africa and in East Africa and in South Africa, but South America now, and in California, and now North America, all over the place, and suddenly exploding across Australia. You know, we know that back in the 80s, and there's a graphic that actually shows that, you know, scientists began to warn something's happening with temperatures globally. And there was a time where, you know, research and understanding was obtained and so forth. And then we saw as we got into time that temperature has continued to increase. And so notwithstanding the debate over cause, I think the important thing is that we're seeing a change.
So Genesis Systems, again, this is your brainchild, is focused on tackling water scarcity head on with a new technology that literally creates water out of thin air. And this is why I'm so excited to be able to interview you today. Okay, so yeah, this is the Genesis Systems water cube. You guys just released this video. Actually, I just got this a few moments ago. I had an older one. This is a promo video that you guys use for the company.
Right.
And, you know, I'm happy to play this because in just a second, we're going to see the water cube. And
this is one of many formats that we're bringing to market. And this one in particular is designed as an industrial system that creates approximately 3,800 liters of water a day. That's about 1,000 gallons a day. If you look at this system, this is a promo video from last September, actually. This is just some pictures of the inside actually making water. And then this is some graphics. But at the end of the day, this video shows 1,000 gallon a day water generator system in 2 containers. And we've squeezed that down into one 20-foot container now. So our footprint continues to shrink while the ability of our systems to create a higher water output continues to increase. So we have operational pilot plants around the country, and they're making water at this moment. And we have a lot of pre-orders going on, and we intend to begin manufacturing these next year in 2023. First and foremost, it's important to understand that really there are 2 dichotomies between the water on Earth. The water contained in the air or in the atmosphere, and the water contained at the ground level or under the ground, and that would be terrestrial-based water. So what's interesting is that from antiquity, from the times of the Roman and even before, from earliest man, humanity has taken its water supply from that terrestrial-based water. We've drawn it up from wells, we've moved it through aquifers, and there's been enormous effort put into that. I remember my wife and I were actually in Tarsus, Turkey, climbing over some aquifers that the Romans had built thousands of years ago, just marveling at these things. We are at a point in human history and human progress where technology is going to allow us to essentially obviate the need or eliminate the need for that infrastructure. The pipelines that go tens of thousands of miles that cost tens of millions and even billions of dollars are no longer needed, because there is the technology that exists now to make the water from the atmosphere at scale. And it's really important that I describe what at scale means, because a lot of folks may misunderstand the definition. Not only does it mean that you can expand the quantity of water that you can make and make as much as you need, say, for a home, residence, or even a city, it also means that as you go up in the amount of water production, that the cost falls. That latter is very, very important, because a solution that is sustainable must also be affordable. And we could talk about early carbon capture from free air as a kind of an example. If you look at Climeworks over in Europe right now, it's heavily subsidized by governments and funders who hope one day that they can bring the cost of each carbon credit, each ton of CO2 captured, down by more than 85%, at which time they'll begin to break even. And at some point beyond that, hope to get into profitability where you make a carbon credit worth doing beyond the potential value of reducing CO2 emissions. Within the water world, up till now, making water from the air has been a very expensive endeavor, right? Most water from air, it costs between $1.50 and 25 cents a gallon. And, if you're in a poor area or a economically challenged area, that's really going to make the challenge worse. And remember, water isn't something that is a want, it's a need. The human body can only live 3 days without it. So when it comes to understanding what we're doing from a design and engineering and scientific development standpoint, we're developing life support systems, because we're going to get to the point where life on Earth in terms of terrestrial water is not accessible for most. Okay, that time is coming, and it's coming very rapidly. For example, in the United States, in 12 to 15 years, most of the Great Plains will be out of water. And we know that because of the rate at which the water is being drawn up from the ground. And we know that by and large, if you look at some of the largest aquifers on the Great Plains, such as the Ogallala, they're withdrawing at about 3 feet a year. And the watershed from rain and rivers and so forth is putting it about half an inch a year back. So like a bank account, you can only withdraw so long and never make the right deposits. And ultimately, you're going to become overdrawn. So as you see this overdrawing happen on these ground sources of water, you're ultimately getting to the point where the wells that are pulling up water to irrigate the Great Plains, these giant crop circles that you've flown over many, many times, they're running out very rapidly. And each time one of those crop circles runs out, you've lost 100 acres to 150 acres of arable land. When I was stationed in eastern New Mexico with the Air Force, we was in the barber shop one afternoon, and the farmers were talking about how many wells were drying up a day. I was around 2011. At that time, those wells were drying up at a rate of between 30 and 50 a day. So if you do the high-end math, that's 5,000 acres of arable growing land, farmland, that we lose every day in the United States. And that is appreciably how we generate food for most of the world. So in terms of this infrastructure, we're anchored into an old paradigm that, again, it dates back to the time of the Romans. It's drawing this water up from the ground, right? It's lakes, rivers, aquifers, these sources that took hundreds of years to charge. So we have to go to a sustainable supply. And what that means is a huge step change for mankind. Sustainability is not just a byword. It's not a political issue, because we have one Earth. If you look at Voyager, right, you really zoom out and look back at Earth from Voyager, it's 81 billion miles away. We're a blue speck, right? As far as we know, all life in the universe is on that speck, right? Until proven otherwise. So right now we've got one planet and we need to take care of it. It's not a political issue in terms of, should we take care of it or not? Good stewardship has always been an intelligent function of a functional society. So what does that mean? Well, since the 1700s, we've had the legend of Johnny Appleseed. Leave it better than you found it. Trees, take care of the world for the next generation.
Yeah.
So this is our human obligation. This is human stewardship. There's nothing political about this. To elevate it into that realm seems illogical to me. So, what I would say is that when you look at IBM, for example, putting up a data center up in on the East Coast, they just spent $34 million to build a 6-mile pipeline from a well to the data center. All data centers use water, thousands of gallons a day, because they have to have it for cooling. So even every time you make a phone call, believe it or not, you use water. And so all of this infrastructure that has been historically needed, the infrastructure that Arizona is considering right now, in terms of bringing water from a desal plant down on the Baja up over land and over mountains to deliver water inland, really not necessary, because the sky provides us what we need. And this new dichotomy means that we can move away from this ancient paradigm of providing terrestrial water and look to the sky. And there's some interesting things, though, that you have to understand. And that is, first of all, how much water is available in the sky.
Well, and so let me come back, and actually I want to come back to the desal plant also that you mentioned a moment ago in just a sec. But so in terms of the scarcity issues, you were talking about the Midwest and the water tables dropping and wells drying up. Now, I guess two examples that I've read about, and they've been in the news, right? So I think most people are aware of this. They're just not sure what to do with it. But one of those is the sinkholes and actually the ground sinking in Texas. And I've seen photos, and I believe this is all in Texas, of telephone poles, right? And the telephone poles are getting taller and shorter because the ground underneath them is literally contracting as the water table decreases. And then you've got sinkholes that are opening up because the water is what was supporting the dirt. And so that is an issue, in that area. And then one that's in the news, and I think you touched on this earlier, again and again and again, is California, especially Southern California, has this incredible reliance on the Colorado River, right? And I keep seeing these concerns about, can the river continue to supply and meet the needs, especially as the population density grows down there? So, that's just for us, right? That's just here in the Western US.
This phenomenon you describe is called subsidence. And it's very interesting because as you withdraw the water out of the ground, the clay layers and sands, they begin to compact. And you can actually see a physical change at the surface, as you described in terms of telephone poles. There's a fantastic photo out there. You can go search it on the internet. But it shows a telephone pole in the San Joaquin Valley in the 1920s. And then it's marked with present day. And the change of elevation is more than 40 feet, I believe. Don't cite me on that, but it is appreciable. It's certainly the height of 4 or 5 vehicles. And so this is happening in Mexico City as well, where the entire basically platform that the city is on is now moving down. And geologically speaking, it's providing its own issues. But when looking at this, now that we're to the point where we see the problem almost beginning to manifest ubiquitously across the world in the areas where most of the population is concentrated, what do we begin to do about it? And so that's where you really have to begin to think holistically. Someone once asked me, what do you need to do to become a good strategist? And I said, you have to know a bit about everything. And they said, well, that's impossible. And I said, then you probably won't make a very good strategist. The truth is, you need to be able to go deep enough to understand the benefits and the risks with each of the things you try, right? So, for example, if you're to try to go solve water scarcity in Mexico City by drilling more wells, well, that's only going to draw the water down adjacent to that well in a cone, right? And then you're going to have many of the adjacent wells running out faster than that deeper well. And then you're going to worsen the problem of subsidence, and ultimately you don't get to solve anything. So a lot of the challenges that we see with communities across the United States it's same with communities abroad, is that they're trying to use the same ideas to accomplish a new problem, and that's not going to work for us. So, we've got to come out and we've got to begin to try new things. So one of the founding members of our company is John Summerall, known as Phil Summerall, affectionately called Yoda at NASA. He's been around since the Apollo program. Wernher von Braun hired him out of the barber chair, and maybe you can have him on the program someday. A fantastic.
Yeah, no, I'd love to have him. I'd love to have him.
But he's one of the founding board members, and I remember that we asked him to speak with our engineers one afternoon as we were preparing for a design brainstorm, and he said, when von Braun brought me in to interview at NASA, the math did not exist yet to do the things we needed to do. And he described a 300-foot tall rocket and all of the slosh of the fuel and how the flight controls would interact dynamically during a launch to keep that fuel from oscillating in such a way as to create what we call an increase in instability. It's dynamic stability, but it's an increase in the instability of that craft. So much so that it would just wobble and crash. The math didn't exist yet. And so von Braun hired him because he was a teacher and he taught math, and they had to develop that. And it was done with slide rules and, all the mechanics that we've had since antiquity, but no computers. And so they solved it, right? And then we successfully put man on the moon. And so, but the vision started a long time before with Wernher von Braun. Probably he had envisioned that we could take rockets to the moon 30 or 40 years before that. And it was this unrelenting pursuit of the technology that ultimately, he brought people along the way with him. And they said, this is possible, right? And they began to see through experimentation and testing that this could actually be done. So the same thing is happening now with the atmospheric water generation technology we're developing. And what we know is a truth, and that is that there is an amount of water contained in the atmosphere equal to about 75 times all of the water contained in all of the world's lakes, rivers, aquifers, and streams. So this is suspended in vapor form. And so until recently, we haven't really been able to go after that in a way that was energy efficient, because using too much energy to go get that water vapor creates its own issues, right? Second and third order effects. In other words, not sustainable. So how do you do that in a way that, flips the old paradigm on its head? And I remember I was talking to Paresh Gianni, who led the Global X Prize Challenge. And somebody had asked us, well, doesn't it hurt the environment when you take the water vapor out? And so one of the first things that X Prize did years ago when they founded their challenge was to do the hard research, understanding what happens to the environment when you actually remove water from the air. And as we get into a period of heating, and back to that chart you showed earlier, think about it like a greenhouse effect. The more you have, let's just say you have a cup of water in a greenhouse. The hotter you heat that greenhouse to, the more water evaporates out of that cup of water that you put in there. But what happens to the atmosphere when the water is evaporated into it? It actually traps heat better, the heat coming into Earth from our sun. So if you think about it, you get a more humid environment that is catalytic. So that more trapped heat in turn causes more heating, which causes more evaporation, which causes higher humidity, and it is a very, very negative direction. And so National Oceanic and Atmospheric Administration, NOAA, has put this, out in terms of research, and the science has proven that global warming actually increases the presence of a second greenhouse gas in the environment. The second greenhouse gas is water vapor.
Oh,
and that
like a sauna. Basically, what you're describing is a sauna. So,
except that the engine of that sauna is the sun, and we're cooking it. So when we actually can withdraw water from the air, it's helpful, right? So we're looking at being able to do this now on scale, on city scale, for the first time in history, and that really has required an intense look at systems of systems. You can't just solve this, by inventing a wing or inventing an engine. You have to do it like the Wright brothers did and put the control techniques with a wing a means of creating momentum or an engine, and you create that system of systems. So that's what Genesis Systems does. We create out-of-the-box solutions for home and office, which will be, I won't spill it here. It's not time to release that information, but there's going to be some interesting solutions come out that would be interesting to all people, especially those in water scarce areas. And then right now, what we do is we create custom solutions for folks who do industry and who need a lot of water. But ultimately, we hope to provide water into all industries and all services, because everybody's going to need it, and it's just going to become a cost of doing business. And so we want to make sure that we do that affordably.
Well, and so I will put links in. I'm going to put links in the interview. I'll put links in the YouTube play, and I mean, this isn't, obviously I don't do commercials, but this is a product, this is technology that I genuinely believe in. And part of it is, I come out of the IT telecom world originally, and one of the big challenges there was the last mile solution, right? And the internet is the same issue. Like you're on Wi-Fi, and one of the things that's been experimented with in cities was something called fixed wireless, which is a little bit like Wi-Fi from building to building, and so that industry has been struggling with last mile solutions for a long time. That's something that water seems like it absolutely struggles with on an even larger scale, because you're not pushing electrons, you're actually pushing a volume of liquid. So, that, to me, that's one of the reasons that I got really excited about this, is you can plop this down, you can plop one of these units down anywhere and start to pull this out of the air. Or if you're doing, like you guys are doing, custom built solutions, I understand that you're talking to various government agencies, various organizations. You could build a plant somewhere, not have it near an aquifer, not pull stuff out of a well, and pull it out of the air at scale. Now,
this is true.
One thing I wanted to touch on, though, before we go too far, was desalination, right? As I understand things, the big difference between what you're doing and like a desal plant is when you're desalinating like seawater, you end up with tons and tons and tons of salt, and you have to dispose of that, and it fouls the filters, right? Is that kind of accurate?
Yeah. So desal is it's certainly a widely accepted means of creating water, and it's especially utilized where you have a shoreline not far away from the infrastructure that you're feeding. I think, since again, antiquity, if you look at the aqueducts that fed Rome, you've looked at very centralized water systems that come from a central lake or a feeder source. And there are extraordinary risks with that. But I think what you're going to see in the future is a federated water system where you begin to generate water locally, and you can do so very affordably. And the Genesis is going to help pioneer into that future. In fact, we call these networks water at the edge, not unlike edge computing. And our tagline for the company is shamelessly water your way. When you are a company, I'll give you an example. There's a beer company in Central California who has, it's a very fast growing company. They make crafts, and, these guys, they bootstrapped their company. It was made to exist because of hard work and American ingenuity. And the city has told them, you're using too much water. Well, they make beer, and they employ more than 50 people, and they pay taxes. And the city says, you're using more than your allocation. So what do? They come to a company like us, and we can say, well, let's make you water on site, and we can provide you portable systems or fixed systems. And let's just give you a new paradigm in water, and you can help supply that. So that actually is supposed to go into a test, actually making beer from our water later this summer. But, to the point of desalination, I'm going to use an extreme example, understanding that this isn't always the case, and you can, not always have this kind of impact. But I will use the Middle East and North Africa as a region. And then if you look at the Arabian or Persian Gulf, same body of water, different names. This is an extraordinary body that supports much of the Emirate states, Certainly it touches Iran and parts of Iraq, and the list goes on. But most of those states along that body of water use desalination. And so real quickly, if we can describe what desalination is, it's just the use of salt water as a freshwater source. And that is accomplished by drawing in about 4 gallons, let's just 4 gallons of salt water. And then they use a reverse osmosis or a squeeze filter to essentially push that water through a membrane that separates the salt from the water. There are a lot of chemicals involved in the process, and ultimately it leaves behind a brine, and it is a very toxic discharge, oftentimes back into the water supply. So what you're finding now is that as you separate, let's say, for instance, 2 gallons of fresh water from that 4 gallons, and now I've got ultra concentrated briny water, they'll push that water back into the sea adjacent, and it is raising salinity over time. So the harder, let me rephrase that. The more salinity or the more salty the water, the harder it is to desalinate. So for instance, Israel can't go take water out of the Dead Sea, way too salty. It would foul the filters. It would not be successful. So there is concern within the scientific community that over time, as you see all of these desal plants exchanging millions and millions of gallons a day, that the Tigris and the Euphrates rivers are no longer bringing in fresh water because Turkey's got dams up at the top of those headwaters. And ultimately, you're concentrating that salt, and you're probably going to have a Dead Sea. Estimates I've seen range from between 20 and 30 years.
Okay.
Do I believe it will happen? I do. Local impact goes without saying. The fish die, the ecology is ruined. It's a Dead Sea. They call it dead for a reason. So, as we push to, move our technology forward and into marketplace, we've been very sensitive to think about the environmental impact. Is this something that is sustainable? And ultimately, the answer keeps coming back that this is fairly settled science. You can use the water that's in the air to meaningfully create water at scale. But the impediment has always been, what is the technology to actually do that?
I'd like to ask about some of the folks in your company. And again, this goes to credibility. This is one of the things that's so exciting to me, because there are lots and lots of startups out there. But when I was doing research for this interview, your board of directors includes names like Lieutenant General David Depula, Vice Admiral Norbert Ryan, Ambassador R. James Woolsey. These are big figures and they have big reputations. And I think that really says something about the social goals and the credibility of what you're doing. Could you talk a little bit about that?
I can. And it was some years ago that, the spark, if you will, the genesis of Genesis happened in a military environment. I was a combat pilot at the time, flying missions in and out of Al-Udeid Air Base in Qatar. And I witnessed Qatar withdraw the last native water supply from their aquifer. And it happened over a series of weeks. And every morning, my sorties were at the same time. So I watched every morning as the tanker trucks pulled that water out. And over time, I began to do a little investigation, and I realized after speaking to some of the engineers at Al-Udeid Air Base and other local folks that the nation of Qatar had about a day and a half worth of water storage at any given time. Well, one of the things that you are taught when you enter military survival training, especially for air crews, is that you have a few priorities in life. And I know that we in America, we spend a lot of time on comfort. But when you start thinking about survival, your priority list rapidly closes to really the top 3. You need to breathe in 3 minutes. You need to keep your body at 98.8 or 6, whatever's normal for you. Some people run cool, some people run hot. And then you ultimately need to have water every 3 days. And you can go as much as 3 weeks without food and you're fine. Okay, so those are really your 3 top priorities. Here's a nation of almost 5 million people with a day and a half worth of water. How dangerous is that? So we're seeing this impingement happen all over the world. This is a national security imperative. And if you think about Egypt, for example, here's a civilization it's older than ours by thousands of years. And always they have relied on the fertile plains irrigated by the Nile River and this water that comes down in the rainy season. But under a significant initiative called the Belt and Road Initiative, backed by China, funding was provided to Ethiopia for a project called the Grand Ethiopian Renaissance Dam. Sounds good. China provided the funding. They built it at the headwaters of the Blue Nile. And now the Nile River is being choked in terms of water supply. And this is a very serious issue in terms of Egypt's national security. And if you go do some research and just hit the headlines, you can see there's been some major chafing over this. We've seen similar happen. And so recently, a body within academia looked at the potential for hydropolitical conflict over the next decade, and that means conflict arising of water issues. And they applied an artificial intelligence algorithm to everything that has happened in the past, and it was right to within like plus or minus 5%. So then they used the same algorithm to project forward in terms of water scarce areas, wherever they could get data sets. And it indicates that the next 10 years will see 75% increase in hydropolitical conflict. So this is a big deal, 75% increase in conflict from water. So water scarcity is the most understated national security risk on the globe, which is, my hypothesis. And ultimately, Harvard finally relented and said, this could be, and then published under that article was one of the early discussions that we had with what I would consider strategists and leaders with vision and an understanding of, past trends and future trends, almost leaders who are futurists, right? So Dave Deptula, for example, was one of the architects of the strategy used in the Gulf War. He brought and helped bring through an air campaign, the fourth largest military in the world at the time to its knees in a matter of hours. He pioneered what we call EBO, effects-based operations, meaning when you hit one thing, it can create a chain of events, and really you need to figure out how to focus on center of gravity, and that reduces the overall effort of the campaign, saves lives, blah, blah, blah. So to me, that's extraordinary and forward-thinking. He continues to lead the Mitchell Institute for Air and Space Power Studies and be a very effective influencer. He's out there in the national media probably daily. Our James Woolsey, 16th director of CIA, has worked under both, Republican and Democratic administrations. And certainly, maybe most people didn't know this, but he was actually the pioneer of the Predator. He pulled that program out of some agencies that were struggling with it, and he put that into use and actually had a live feed into his office at one point when he was director of CIA. And, that was pioneering at the time. Now, this form of using these aircraft for warfare to save lives is becoming accepted. There are now wings in the Air Force with, remote pilot wings. They're special wings. And those pilots, that's what they will do for their entire career. Navy's going the same direction. Recently, Navy had an aircraft shot down abroad. And the commander of that squadron was recently telling me how thankful he was that there was not a pilot on board that aircraft or a crew. And that saved lives.
Yeah, and see, and the reason I mentioned your board was these are remarkable people. They would not put their reputation on the line if they didn't believe in the goals and if they didn't believe in you. So for me, that's just a testament to what you're doing.
First and foremost, we had to start with a vision, and it was one that I think Kennedy said it first, and I think he said it well. He said, we do these things not because they are these things and other things, and as well as go to the moon, not because they are easy, but because they are hard. And so we brought together visionaries like these founding board members, like Deptula, like Admiral Woolsey, because they had done extraordinary things in their life and accomplished a great deal of activities. And they know how a few visionaries can come together and actually influence the affairs of humanity. And they also knew the data, because we showed them the data in terms of where water scarcity was going and the fact that scarcely anyone was working on the problem, during those years that we needed to really get ahead on things. And so today, we've developed some of the most sophisticated atmospheric water generation systems on Earth that can help us create a federated network of water, or water at the edge. And for the same reasons we've had interruptions to the signal on this, interview, because we have a centralized system. We can actually federate water and create higher resilience for humanity, right? So that if that centralized water system goes down, Tim Ventura's family's still up and going. And the same goes for maybe a military installation and other pockets around the city. So to us, there's a national security element as well as a humanitarian element to what we're doing. And it is just an absolute pleasure to be involved with this team and see their hard work paying off as we move the needle on technology. And so watch for things in products to be launched in 2023 from Genesis. We're taking pre-orders now on WaterCube 5.0 system, which is our 1,000 gallon a day generator. And we're just continuing to make the technology better and more affordable, because again, our goal is to create the lowest cost produced water on Earth, and that is sustainable. So this certainly is sustainable. And I really appreciate your interest in this topic. I know you've been someone who's been following water trends, and you're early in terms of thinking because you're a futurist. So it's always fun to talk with other people who have a like mind.
Absolutely. David, thank you again. Thank you so much. Thank you again for your career of service, and I guess for having the vision to tackle this challenge head on. It's very exciting.